stable and unstable atmospheric conditions. Okay, atmospheric conditions. And now tell me which is actually very important for us and which is a good unstable. And why, on what base you people say it's unstable is good? Because unstable means it's a lower pressure, or else you can say that's whenever the unstable condition occurs in the atmosphere or weather, okay, it ascends the air indeed. Or during this condition air ascends, the ascending air is favorable condition for cloud formation or rainfall indeed, isn't it? Yes. And after the stable and unstable condition, that's already we have discussed. Okay, fine. The zones based on temperature, the same thing. That's a tropical zone, temperate zone, the polar or frigid zone, we can say. So 3 types, isn't it? Tropical, temperate, then frigid zone. That's also we have discussed already, isn't it? Isn't it? Yes. And the 5th one, again you had to go here, is the layers. The layers of atmosphere. The layers of atmosphere. And now just I am writing what it is. Yes. What phase it is? Surface phase. Surface phase or surface? Surface. Okay, it's not surface. It's a surface, isn't it, Aisha? Yes. So already we knew it. What we knew it? Suppose if you are taking it as what? Altitude. Okay. And now, so as already we knew it, right? What we knew, and as we go up, temperature drops, right? And this thing actually we knew it, isn't it? And okay, I'm writing that like this, isn't it? So what happens as you go up, temperature drops. This is actually called as environmental lapse rate, or it's an open system, or adiabatic lapse rate, isn't it? Isn't it? With respect to the air parcel, and we can call it as adiabatic. With respect to the surrounding, we can call it as environmental. That's it. Bandru. So that's we can say. So yes, you need to know the transition zones will be there, isn't it? Suppose if I say, this is one zone and this is one zone. Okay, the characteristics of these 2 zones should not be similar. Okay, it is not like it. Okay, it is not like they have to be in the same way, isn't it? Maybe the density of this zone would be different compared to this. Can I say? Similarly, okay, after this maybe, okay, I can tell you, and around at the kilometers of 10 to 12 kilometers, we have what? Ozone. And maybe that's again, ozone is one of the greenhouse gases. The greenhouse gases means it can absorb the terrestrial radiation, and it absorbs the terrestrial radiation means what happens to the temperature of that area? Will increase, isn't it? Okay, that's, can I say, because of the presence of this, the presence of O3, the temperature of this would be more, and therefore can I call it as, okay, similarly, samajh mein aa raha hai? Temperature will increase. Getting my point? Right? And one more thing you need to know here is, okay, I'm writing some base here. I'm writing some base here. Okay, from here up to here, the heat of, okay, or else I can say heat source is terrestrial radiation. Getting my point? The heat source is terrestrial radiation, that is surface. From here, heat source is, sun, isn't it? Right? Now tell me, and as you go up, what happens to the the temperature, it has to decrease, isn't it? Because as it goes or it goes away from the source, so the temperature, okay, so usually we knew it, and it decreases, right? Okay, can I write? Okay, like this. Temperature decreasing, and why here it is increasing? Because of the presence of O3. That's it. Otherwise, it would have been written like this. Okay, suppose, okay, I am writing here, it had to be or it has to be like this. But here what we have, yeah, that's it. Getting my point? Yeah. So as I told you, okay, maybe the density or characteristics of this zone and this zone same or differ. There must be difference, right? And that difference can be marked by, yes, some, okay, what we say that. So there we have discussed what we said, discontinuities. In geomorphology we have discussed, isn't it? And similarly, there has to be some discontinuities. Getting my point? Getting or not? Okay, discontinuities. Getting? Clear?
Yes.
Right? And similarly again, getting? And after that, what you can write? Yes, it will increase. Why it has to be like? Okay, and here, so what is actually happening with the temperature? Temperature is increasing, and here is temperature decreasing as you go up, right? And as you go up, temperature will increase. Temperature will increase. Temperature will decrease. Clear, right? And here, so we can find that non-atomized particles, because as it is away from the sun, and again it's receiving heat from where? Surface. But this area is getting directly from sun. That means sun is source of atomized or ionized particles or molecules. As we discussed plasma and all, the source of the energy in the sun is fusion, right? The fusion means it produces some radioactive elements, that means of the charged particles. Therefore, from this here you can find many charged particles. Isn't it? Because directly it is heating by, or heated by whom? Sun, right? And therefore we can say the zone of charged particles. Charged particles. It's a zone of charged particles. Getting? Zone of charged particles. Fine. And similarly you can find here, after this I am writing, okay, after this I am writing, okay, you can be, okay, divide as ionosphere, okay, ionosphere, thermosphere, and you can write as exosphere. Okay, exosphere. Exo means outside. Yeah, you can see directly it is outside. Okay, it is outside. Right? And similarly you can say these are transitional zone, right? Right? Okay, look, now one by one we will discuss. Okay? The first we have, okay, this one. Okay, and what is the character of here? The characteristics of here, the temperature decreases with increase in altitude because of as it is moving away from the sun, isn't it? The concept of, you can write here is ELR and adiabatic ALR, that is adiabatic lapse rate, you can, and you have to write one thing. Another very important thing in this our atmosphere, the atmosphere means the blanket of different gases. That means we can find there is a the rapid mixing of the the gases or gas molecules, isn't it? So therefore, due to the rapid mixing is present here, and that's why the tropo here means is rapid mixing. Tropo means the rapid mixing, isn't it? Mixing of what? Gases. That's why this sphere is called as troposphere. Okay, we can call it as troposphere. Why we can call it as troposphere? Because the rapid mixing of the gas molecules actually happen or occur here or take place here. And one more very important thing what you have to know about this troposphere is, and what are the all weather or climatological conditions what we are going to discuss in coming classes, and everything, and those all activities and mechanisms, they are this is the place where they originate or where they decay. Their genesis and their decay can only happen in this zone. If I ask you where rainfall takes place, troposphere. Where you can say that cyclones take place, troposphere. All the weather related or climate related the activities and mechanisms only takes place in this area or in this zone, you can say. Clear, right? And if they ask you to write a short note on troposphere, can you able to write? Right? And if you read, look, how to approach the exam, and if you read thoroughly, automatically it covers both, that's the prelims as well as mains. And if you read for mains, automatically you will cover prelims itself, and they can ask you where the clouds and other whether our climatical conditions occur. This is prelims. Getting my point? Automatically if you read comprehensively, both prelims and mains will cover. Getting my point? That's why you have to read in a comprehensive way. Integrated way we say. Clear, right? And after this, as I told you, now tell me, so what is happening here? Temperature is decreasing. But when it reaches this point, the temperature, becomes what it is? Constant. Temperature becomes constant. Getting my point? The constant means the constant with another synonym can be force. Constant or you can write as force. So force of what? Tropo. That means you can say it's a tropoforce. Tropoforce. And the tropoforce means here you can say it is the constant, the temperature constant, or sometimes you can say it's a very coldest. If you compare where is a more temperature, troposphere or tropoforce, it's a troposphere, because in tropoforce we have the constant or somewhat very less temperature, a very less temperature you can find, right?
Yes.
Clear? Yes. Now, and after this we have what? O3. O3. And relatively tell me, what about the temperature here? Right. And if the temperature is more, what about, the density of the air will decrease? It's simple common sense, the density will automatically decrease. And if the density decreases means, what about the resistance force there? Resistance force to, for anything to flow or anything to move. Move to less, right? Less, right? For example, if you have more denser weather, just assume this room is filled with very highest or more dense air, and then just assume yourself, right, what the resistance could be exerted by that system. The resistance will be relatively more or less. Density more means resistance will be more, right? And if the density decreases means, what about the resistance? decrease, right? Relatively less, right? And if the temperature is more, the density will be less, and if the density is less means the resistance force would be for anything to move over that area zone will be the resistance force will be less. That means it can support the movement, right? Okay, it can support the movement, isn't it? Getting my point? That's why this zone is used for flying of jets. Flying of jets. Okay, flying of jets you can say. Okay, and due to the less density, always air flows in layer manner. Okay, in horizontally it flows. Air here is always flows in horizontal manner. Okay, because we can say that it's one of the reason for the geostrophic winds. Okay, we will discuss later. Okay, geostrophic wind. Okay, later we will discuss about it. And but just you can now the air flows in horizontal, means in straight line. Okay, that's why because of the straight line it is called as stratosphere. Strato means layer, straight layer wise. Okay, so therefore it is called as stratosphere. Stratosphere. And the most important thing, while you are explaining about this layer, and you must know the relevance of O3. It's a very, very, very important, and for your examination is concerned, and that's why, so knowing about it is very important. Getting? And now, and if I talk about this O3, right, O3, okay, look, and how we can approach this. The first thing you can say what it is. What it is? What it is? Yes, it's a molecule with three O3. Sorry, 3 oxygen. Okay, not O3, 3 oxygen. Isn't it simple thing, right? Okay, second, nature. Good or bad? Yes, you can write it as both. Good. Okay, second, bad. Okay, both it is. So, good as well as bad. Now, we will discuss about the good. Why it is good. Isn't it? Sir, why it is good as we knew it, and the sun is also source of UV radiations. A, B, C, and the most dangerous is UVC radiation. And if without this, the O3, the UV radiation can directly hit into the Earth's surface, and it could cause the skin cancers and other, and even it is not good to the biodiversity. So here what this O3 does, and O3 filters those harmful UV radiations reaching into the Earth's surface. So now tell me, it's now good or bad then? It is good, isn't it? If it is good, and what is our role here? We need to protect it, or we need to reduce that O3 molecule over there. We need to protect, right? So therefore, if you want to protect the O3, we must know. Suppose if I ask you, right, about the problem, what is your problem? If I ask you, and how you can find the solution, and in which way you can find a better solution? By understanding the problem. Without understanding the problem, you can't reach to the proper conclusions or solution. So therefore here also we understood that, and it's a good because it filters out the UV harmful, that is C radiations reaching into the Earth's surface or ground, Earth ground you can say. So but the second thing, because of this quality, and we need to protect it. We need to protect it, and why we need to protect? And because it is protecting us, that's why we need to protect it. And if that word, if I am using here, that's a protection, means maybe it is under threat, right? Without the threat, I can't say need of the or need for the protection is important or vital. Isn't it? If I am saying something, it's a need for the protection, means it's a very important that it is under danger, at danger condition. So therefore, what is the dangerousness to this? Okay, before understanding that, and look, okay, I'm talking about here good. Okay, then you can write as next third one, good ozone, concept of good ozone. Concept of good ozone. Okay, the next is the third one, concept of good ozone. In the concept of good ozone, so what we have to know first thing is, okay, what do you say that? So role. What is the role of it? You can write it as it is protecting us from the harmful UV radiation. You can write like that. Why it is good? Because it is protecting us from harmful UV radiation. That's the role of it. So, if so, and next what we have to know, the threat that is encountering, or okay, what is the threats is actually there to our O3. Okay, and before that, one thing you can add, where you find the good ozone, in which layer? Stratosphere. Isn't it? We are discussing about where about it. It's a stratosphere, and we can say the location of the good ozone. Okay, threat we will write later on, but before that, one more point we have to add the location. Where we can find this good ozone? Stratosphere, right? At stratosphere we find.